In this series of videos, we're going to see how to parse JSON in an Android app. There are several steps involved here. First of all, we need to use an async task to spawn a new thread, or we can use another threaded model, but async task works very well in Android. Next, we need to add internet permission to Android manifest XML, and after that, we need to make a network connection. That's the focus of this video, making the network connection. We've done the async task previously in a previous set of videos, and the permission is an easy one to add. After we make the network connection, we need to read data, and then we need to parse that JSON data into a DTO. In other words, we need to take a string of delimited data and turn it into a series of objects in Java. Alternatively, we can just use retrofit in JSON, and it will do all of the steps above for us except the one about adding the permission to the Android manifest. We have to do that either way. Now, if you're watching this video just because you have a stream of JSON, you need to convert to Java objects. I'll go ahead and point you to the retrofit video I've done. 20 minutes, covers the whole thing. So that's a nice, easy way to do it. This way is going to be a piece-by-piece approach. Nonetheless, there are pieces of this video series that could be used in another context. For example, you might want to make a network connection to do something else, to read some data or to submit some data. So let's focus on making that network connection. We know the first thing we need to do before we forget is to add the permission, Android permission internet, to the Android manifest file. Now after that, let's remember where we left off last time. I'm going to go to GPSAplant, and we have an async task method that we set up to read data from a network stream. And if you take a look here right now, we just have it going to a dummy stub, the plant DAO stub. But that plant DAO stub is stored in a variable of type iPlantDAO. And iPlantDAO is an interface. One nice thing about an interface is that we can keep this variable declaration the same even if we change the object type that we're creating and putting into that variable, under one condition. The object type that we're creating here and storing into the variable must implement this interface iPlantDAO. So let's look at iPlantDAO, and we see that it's a simple search method. It accepts a search term and returns a list of plants. It's currently only implemented by a hard-coded stub. So let's make an implementation class for this. I'm going to right-click and I'm going to say New Java Class. And because this is a JSON parse, we're going to call it Plant JSON DAO, just like so. Superclass we can leave alone, but the interface is what's important. Let's have this implement interface iPlantDAO, and you see it auto-completes for us. Now I choose OK. Now, do I want to add to get? Yes, I do. Now, it redlines immediately, and we know when we see a red line, we want to fix it immediately. So we choose Implement Methods, and take a look at the method that it wants to implement, the search method that accepts a string and returns a list of plants. And I choose OK. Now, what this is eventually going to do is come out and hit a little JSON API that I've created on plant places. Notice that the search term here, combined name equals oak. I could put red, and it's going to give us back any plants that have the word red in it. I could say red bud, and it's going to return to us a series of red bud plants. So a little kind of almost like a REST-like interface that's going to give us a JSON stream of data. So what we want to do is we want to make a connection to this URL, and we want to leave this combined name as something that can be configured. So it could be red, red bud, or oak. Now this method is going to play right into that because the search term is essentially that red, red bud, or oak that we put on the end of this URL. The list of plant DTOs, well, that is taking these strings, each of them represent an individual plant, parsing the string based on its delimiter, the comma and the quotes and things like that, and then turning it into an object of our plant DTO type, which we've created earlier. Remember, this plant DTO has a GUID, cache ID, so on and so forth, a few other things. So that's our eventual goal here, but first we need to make some kind of network connection, and we need to pass that network connection a URL. So let's do these things one at a time. First of all, I always like to declare the return type at the top of the method because leaving return null, it's too easy to miss that and forget to replace that. So let's go ahead and declare our return type now. We'll say list and then plant DTO. So a list full of plant DTO objects. We'll call it results equals new array list, and then the generic identifier again, plant DTO. Open and close paren for a constructor call and terminate with a semicolon, and then Alt-Enter will import that array list, and then we simply return results. Okay, next we need a URL, so we'll say string URL equals, and then what URL are we going to use? Well, how about we start with this one that I have, but we'll take off that redbud term. So we'll say string URL equals double quote, and then we'll just leave it all the way up to the equal sign there on the right without the actual search term, because the search term is what's getting passed into us right here. So plus search term, just like so. Whoops, search term, just like so. Okay, now we need to access the network. Now this is going to be a low-level network function, something that is just going to get data kind of without knowing exactly what the data is all about. So I'm going to right-click and I'm going to choose New, Java Class, and I'm going to call this Network DAO. No need to extend anything or implement any interface. And I will tell you this Network DAO that we're about to create is a lot of boilerplate stuff. And this is a class that I have used in multiple Android projects verbatim. So just data in, data out. Give me the URI and I'll give you the data in return. So feel free to just copy and paste this. As a matter of fact, as I work through this, I might not explain every single nook and cranny because some of them are just too detailed for our use. So we'll say perform common data agnostic network operations. So in other words, I know I'm doing something over a network, but I don't really care what the data is coming in or going out. So for this, I'm going to say public string request and then string URI. Okay, open curly and close curly. Let's put a little javadoc on the top of the method where javadoc belongs. So we'll say return the data found at the given URI. Okay, URI. The location for the data. Okay, return the raw data found at this location. Okay, now what are we going to do? So we need to return a string, and you know that I like to declare my return value up front. So normally we might say string results equals da-da, and then say return results. But I am going to think a little bit forward in this case. In this case, I'm going to be reading from a JSON stream and potentially many lines from a JSON stream. So it's not very efficient to use an old school string because anytime we concatenate a string, we end up with a new object in memory. And if we're in a loop, we can end up creating a whole lot of objects that are wasted memory. So I'm going to use something a little bit more efficient. I'm going to say string builder, which this is a class that we use when we know we're doing a lot of operations on a string. And then SB equals new string builder. So the string builder class is a bit more efficient way if we're concatenating or adding together a lot of strings in an operation. So for the return, I just say SB.toString, and it takes that entire string builder object and then creates a final string out of each of these subcomponent strings we've been throwing into the string builder. Okay, deep breath. The next thing we need to do is to construct a proper URI out of our string. So construct a URI in the correct format. In other words, a string is kind of dumb, really. It's just a series of characters. But a URI indicates something that has a location. Specifically, could be a location anywhere, but many times we use it to indicate a location on the internet. So I'm going to say URL. Actually, it should be URL, shouldn't it? We'll say URL, and then we'll say URL equals new URL. And we'll pass into the constructor for URL, Alt-Enter to import that, we'll pass in the string URI that was passed to us. So here we go, URL equals new URL, and then we pass in the URI. Oh, okay, what's this? Unhandled exception, malformed URL exception. So what that means is we're taking a series of characters and turning it into a URL, a universal resource locator. But we know that URLs tend to have a specific syntax. If we look at this one, we know that it typically starts with HTTP, although commonly browsers will hide that from us because just about any website will start with HTTP. Then we have a domain name and then a series of directories and then a little script that runs. And then after that, we have parameters we're passing to that script. So a URL has to have a certain kind of syntax. So what it's telling us here is, what if the string does not have that syntax? Well, remember the best practices flowchart we talked about for exception handling, which is if a checked exception occurs, number one, that means that I'm dependent on something external, and we need to figure out what to do when that something external goes wrong, when something doesn't work properly. So what are the proper behaviors that we can do? Well, we can catch the exception, but it only makes sense to catch the exception if we can fix it where we are. Number two, we can throw the exception. Throwing the exception makes more sense if we can't do anything to fix this issue and the issue was initiated somewhere else. We can also catch the exception if we're in a user interface layer and we want to send a message to the user. So let's think about those three options. I'll do them in reverse. Can we, or I'll do them in a random order actually. Are we in the user interface layer? No, we're not. We're in the DAO, so we need to strike that one, which means we don't want to catch the issue here and show a message to the user. Now another one is there anything we can do to handle this locally, to fix it? Well, the string URI is getting passed into us from the previous class, which is plant.json DAO. So plant.json DAO, or whoever's calling us, should have the correct syntax. We're going to trust that they do. If not, we need to throw it back to them. So that's what I'm going to do in this case. I don't have enough information to fix it. I can't handle it locally. I'm not in a UI layer, so I'm going to Alt-Enter and add the exception to the throws clause. That just means that we're now rethrowing this exception into any class or method that's calling us. And we're telling that class or method to handle this exception because we don't know what we need to do to handle the exception. Okay, next thing we're going to do is open a connection to this URL. So we'll say URL.openConnection, and notice that responds with a URL connection. And we want to store that into an HTTP URL connection, which is a more specific type of connection. So HTTP URL connection, and we'll call that simply URL connection equals URL.openConnection. Okay, first of all, HTTP URL connection does not like that one because I need to capitalize the R and the L. There we go, just a little miscapitalization. Now I need to import it. Alt-Enter will handle that. And now it says, what's going on here? Alt-Enter? Well, guess what? URL.openConnection is another one that will throw an exception. And is there anything we can do to handle the exception here in our network DAO class? Not really, because the network DAO class is pretty much an unintelligent class. It's just making a connection and returning the results to us. It doesn't know anything about this connection. So let's add another exception to the method signature, and in this case, it's actually a more general exception for the one that we were already throwing, so it just kind of consolidates and throws IO exception. Now we have yet another red line. And this red line says that URL open connection doesn't know it's returning an HTTP URL connection, so we have to cast. This is a case where the context-sensitive help in Android Studio is quite nice because it's going to help us do this. In other words, it's going to do it for us. And that's quite nice because casting is confusing. I can talk about it over and over again. It will still be confusing. The IDE does it for us here. Makes our job a lot easier. Okay, so now, with any luck, we have a connection. And by the way, what would happen if an exception happened here? It would throw the exception and skip the rest of this method. If an exception happens here, on this URL open connection, once again, it's going to skip to the end of the block. It's going to skip everything I've highlighted in blue. So if something goes wrong here or here, it's going to essentially abort this method and return back. Okay, now, we have an open connection, and what we need to do is get an input stream and a reader. So get an input stream to read the bits, and then get a reader to turn the bits into a string. So get an input stream to read the bits. So the zeros and ones that are coming across this network connection. What I'm going to do for this is say URL connection, and then I'm going to say .get input stream. So in other words, get the stream of data that's coming in. Now, we want to be able to buffer this, so we don't want to block and read everything all at once. We want to be able to read this in chunks. So I'm going to put this into a constructor. Actually, tell you what, I'll do it in two steps. I'm going to put a semicolon here, and then introduce local variable, and you see that's called InputStream. Just a little more clear if I do it in a couple different steps because this tends to get kind of unwieldy after a while. Now I'm going to say new buffered input stream, which means don't read it all at once, read it in chunks, make it a little more manageable. And I'll say input stream. So we're just doing a little bit of wrapping right here. Now for that I'm going to save it into a variable, buffered input stream. And we're going to call that input stream. We'll call it, I'll tell you what, let me rename a little bit. We'll call that one buffered input stream. That's fine, because I'm already using the input stream above. So buffered input stream equals new buffered input stream. Okay, get a reader to turn the bits into a string. So for this I say new buffered reader, which knows how to work with an input stream and knows how to read one chunk at a time. And for that I say actually I'm going to break this one into two separate lines again. Hold that thought just one moment. Let's do it this way. We're going to say input stream reader, input stream reader equals new input stream reader, and then buffered input stream. This is why I say it's a lot of boilerplate stuff, because it feels like we just keep making new objects and making new objects, but that's kind of a chain of events that's happening from opening a stream of data to reading it at the right rate, reading it buffered, one piece at a time, and then to looking at the data and deciding should it be a string, should it be an int, should it be something else. It's all part of that journey. Okay, now we can pick back up where we left off. So we're going to say buffered reader equals new buffered reader, and we're going to pass into that our input stream reader. Okay. Now what we need to do is read one line at a time. So we're going to say string input line equals buffered reader dot read line, just like so. So that's reading one line at a time from the stream. In other words, if we consider the data that we're going to find at our service endpoint here, it's going to read line 1, then line 2, then line 3, so on and so forth, one line at a time. So we have to put this into a loop, and the loop construction is going to look a little bit tricky. I'm going to say while input line does not equal null. So while there is something there for us to parse. While input stream is not null, open curly, because this is a while loop, close curly, add this to our running string builder. So we'll say sb.append, and then we'll say input line, whatever we read in. And then we need to read the next line. So here we're going to say input line, which we declared up above. We're going to reassign it to BufferedReader.readLine, like so. Okay, so looking pretty good so far, but one thing that and by the way, notice this sb.append input line. That would be like saying string result equals result plus input line. Those are essentially the same with only one note, and that is that this plus operation is what is a bit inefficient, because when you see this plus operation with a string, that means it's creating a new object each time you see that plus. That's why we like the string builder. It's a bit more efficient at that. It's essentially going to bundle everything up and then return one new string down at the end. So that's why I did it that way. One more thing we need to do though. This connection, the URL connection, we opened here, we eventually have to close. And it's tempting to say, oh yeah, okay, so I'm going to say UrlConnection, and then we'll say .disconnect, like so. That might work, but there's a bit more foolproof way to do it. What if one of these intermediate lines threw an exception? Remember what happens when an exception is thrown. It skips everything else in the method and returns. So if an exception happened anywhere in this blue area, or really anywhere in this blue area, we would be leaving an open connection to this URL, which would be inefficient and would eventually eat up a lot of memory. So we need a way to make sure that we close that connection whether an exception happened or not. And this is one of the interesting nuances of a try-catch block. Even though we are throwing all of our exceptions to the calling method, we can still implement a try block with try up here And actually, we don't need the catch. I'm sorry, we don't need a catch. All we need to do is do a close curly and then say finally. And in here, we're going to say UrlConnection.disconnect. The advantage of doing that in a finally is if all of this executes properly without error, this is going to run. If something here throws an exception, it will skip the rest of the block. However, it will go ahead and do whatever's in the finally. So a finally will occur whether an exception happens or does not happen, and this is usually a good place for us to do things like clean up any open connections. So we're looking pretty good here. At this point, I believe we're just about done with our network DAO, unless, of course, I've forgotten something. Let's go to our plant JSON DAO, and let's pick up from where we left off there with access the network. So we'll make an attribute of this class called network DAO. Network DAO. That's better. Network DAO, just like so. We will, in our search class, we probably could make a constructor for this class. That's probably, why don't we do that? So public plant JSON DAO, make a constructor like so, and then we'll say network DAO equals new network DAO. So you see we're simply creating an object and we're storing it into that variable called network DAO. Now in the search, let's say network DAO, and then let's invoke that request method. And what are we going to pass in? The URL that's defined up above. Notice that this guy now says, oh, wait, what's going on here because I have an exception. Well, once again, we can ask ourselves the same question. Can I heal the exception locally? If not, do I want to pass the exception up? In this case, it's a little tricky because we do want to pass the exception up, but the trick is that we have to match the signature of our interface, the iPlant DAO. So we have to say, yes, let's go ahead and alter iPlant DAO, give it the same exception. Then that means we have to change the stub that we created before because now that's out of sync. So for this, we also need to say throws IO exception. So a little chain of events that happens there. And while you can't always do it, if you can think through the exceptions that a method might throw when you're defining the interface, not a bad idea to do that there. Save yourself the hassle. One trick is that does cascade back to GPS a plant because we're invoking this method search, and that now throws a checked exception, which it didn't before. So the nice thing is we are in the user interface here, so we can go ahead and surround it with the try-catch block, probably put in some logging here, but we might want to do something to message the user. This is a cop-out, just doing an ePrint stack trace, but nonetheless, I'll go ahead and set a couple of breakpoints here so we can watch this process. Now, while I'm here, I noticed one other thing, which is I need to change the constructor call here. I no longer need to use the stub. I can now use the actual implementation because I now understand that implementation. So I simply change the constructor call to plant JSON DAO. Notice that nothing else needs to change because the variable is the interface type, and remember polymorphism, variable type tells us what methods we're allowed to call, object type tells us what will actually happen. So in this case, we are the variables that we call, like search, those aren't going to change. I'm starting this in the debugger, as you might see. Let's look as the debugger comes up. You see that the UI is currently blocked, but that's to be expected because we are on the onCreate method, and we know the onCreate method is the method that starts our activity. So in Android Studio, F9 tells that to continue, and as soon as I say continue, the UI renders, and we also go into our doInBackground method, but remember, doInBackground is a method that's operating not on the UI thread, but on a separate thread. So in Android Studio, F8 means execute this line, move to the next. So I choose F8, and notice now we're on the line where we're declaring the variable called plant DAO, and we're creating an object and putting it into that variable. Let's choose F7, and notice in F7, we're stepping through and creating a new object of type network DAO in the plant JSON DAO constructor. Step again, step return, and now our plant DAO should be properly constructed and should contain an object, and sure enough we see it contains an object of type plant JSON DAO, so it looks like we're in pretty good shape. Now we get our search term, which was passed into us. Let's see what that search term is. It's the letter E. So we're going to get back a lot of results, essentially any plant that has that letter E in it. Now, once again, look carefully as I choose F7. Remember, F7 is the key to step into a method, and here the method that we're stepping into is a method called search. So watch the tabs up above as I choose F7, and you'll notice that we're going into the actual implementation class now, plant.json.dao. So create our new array list. We're not populating that yet. Okay, and here's our URL. And now let's go into our network DAO. So again, watch the tabs across the top as I choose F7. F7 is going to step me into this request. So F7, and here we are in our network our network DAO. We start our string builder. We parse the URI. So far, no exception is thrown because if an exception were thrown, we'd be out of this method. So looking good so far, but still a lot of uncertainty to go. Make the connection. Open the input stream. Read the input stream in chunks. Okay. Put it into a buffered reader. That allows us to read it one line at a time. F8, what does the first line look like? I mouse over and you see plants, square bracket. Let's compare that to our JSON stream, and what's the very first line? Plants, square bracket. Okay, F8, let's append this to our string buffer, and let's keep going. Second line around is ID 3121, begonia, and let's see, I'm going to do this one more time, but we'll do combined name equals E. And what's the first plant that we see? This will take a moment because it does have to read quite a bit of data. But sure enough, the first one we see is begonia, whopper red with bronze leaf. And if I mouse over this, we might be able to see that entire line. If not, I won't worry too much about it. But it should be begonia, whopper red with bronze leaf. Pulled up in variables, just a moment. And begonia, whopper red with bronze leaf. If you can see it just at the tail end of the variable stack here, you can see that's there. Okay, so it looks like we're able to read data, and I can keep F8ing here, but it's going to read every single line of this program. Might be more efficient if I just say F9, which is continue. Now that takes us back to our plant.json DAO class. Remember this little class, we have a bit more to add to this, but we do just want to confirm that we're getting back some data that we expect. So I mouse over request, which is a string that represents all of that JSON text that we've received from this URI. It's going to be a little tricky to get an idea of what's in here, but if you see, I can scroll and we see quite a bit of data here. I can keep going and going and going. We see quite a bit of data here, and if we were to do a one-for-one match, we'd see that it matches exactly what we have here in the browser. So, short version, that's a look at how we're able to access network data from an Android application. We still just have this in a raw data form though. The next thing we need to do is actually parse it in JSON, and that's what we'll see in our next video. I look forward to seeing you then. Thank you.